Good morning, good afternoon, everybody, wherever you're joining us today. Welcome to our first qbiss One design webinar. I believe this will be a good start to the first one of many. My name is Andras Marincic, and today I will be joined by my colleague Jure, also from Market Engineering Development Department, where we focus on building a strong link between our customers and Trimo's internal departments. We are located at Trimo headquarters in Trebnje, Slovenia. All right, before we get started, we'd like to let you know first, feel free to leave questions in the Q&A section, and we'll try to answer them at the end of the session. And secondly, the session will be recorded and it will be placed on our YouTube channel, and you will get the link afterwards. Now let me quickly walk you through today's agenda. Since this is our first webinar about designing with qbiss One, we'll start with the basics, so everyone understands the product itself and how it's made. We'll begin with a short qbiss One presentation, how it's produced, what materials are used, and some key technical properties. That part is really important because knowing and understanding the background helps you design with the system correctly, efficiently, and with more confidence. Here I'd like also to highlight one major advantage of qbiss One compared to standard facade systems. Each qbiss One element is manufactured to exact dimensions in the factory and arrives on site completely ready to install, without any need for cutting or adjusting on site. Because of this, accurate design and detailing in the early stages become even more important. Then we'll look at the fields of use, showing where qbiss One can be applied in different types of building setups. And once we'll cover the fundamentals, we'll move into the designing with qbiss One in AutoCAD. Here we'll demonstrate how to use our dynamic blocks and how you can export data directly from your drawings. Next, we'll explore the interactive cutting list, which allows you to easily generate and manage qbiss One elements together with all the necessary accessories. So that's the plan for today. And now I'll pass the word to my colleague Jure, who will start with the first part.
Thanks, Andras.
Okay.
The production of qbiss One facade elements followed the EN 14509 European product standard, which is specifically designed for self-supporting double-skin metal-faced insulating panels, also known as sandwich panels. The fundamental building block of the system is the qbiss One modular wall element. This element is created using a highly automated robotic production line, ensuring precision, repeatability, and consistent quality. During the process, pre-finished steel sheets are bonded to a non-combustible mineral wool core, resulting in a robust prefabricated facade element. Since every building has its own requirements, the product is always tailor-made on a project basis, customized to meet the architect's design intent and the client's functional expectations. Each element is defined by two main parameters, the length and the model width. When panels are assembled on-site, they form longitudinal and transversal joints that ensure structural integrity and weather tightness. For cost optimization, widths are carefully combined, especially those with differences of just 1 millimeter, allowing precise design flexibility while minimizing waste. Basically, to summarize, fewer modules you have, better price you have. The process of the production of qbiss1 panels involves multiple closely controlled steps combining advanced machinery with strict quality supervision. The qbiss1 panel is made on two different production lines and then bound together in the final stage. This is Trimo production line and this is qbiss production line. The process on Trimo line begins with steel decoiling, roll forming, and sheet alignment, which prepare the inner metal sheets. What's important is that steel coiled width is procured according to widest project module. Therefore, any smaller modules means additional production line setting, cutting procedure, as well as additional material wastage. And this results in higher final cost and is related to previous slide when we talked about the cost optimization with fewer module sizes. At the same time, mineral wool is cut to corresponding thickness and prepared as the insulation core. Adhesive application and pressing then ensure a strong and durable bond between layers. Additional gasket application and sewing of the panel concludes our output on a Trimo production line, which we like to call a topless panel. This consists of the bottom or internal steel sheet combined with the mineral wool insulation. Separately, on the qbiss production line, the distinctive qbiss1 metal cover is manufactured. And then in the final bonding stage, adhesive is applied to the cover, which is then joined with the topless panel, creating the complete facade element. If a project requires prefabricated corners or any other special panel treatments, these adjustments are completed afterwards in our workshop. Now, the dimensional tolerances of qbiss1 panels comply with the previously mentioned EN 14509 standard and are further refined according to the system's internal specifications. Strict tolerances ensure that panels fit perfectly during installation, eliminating any delays or costly adjustments on site. What distinguishes qbiss1 is the controlled factory production, which guarantees precision, consistency, and long-term reliability. This gives contractors confidence during installation and allows for easier handling of after-sales service if ever needed. To achieve this level of assurance, the production line includes continuous checking of the dimensions and flatness of incoming raw materials, camera monitoring of production steps for traceability, and systematic measurement and recording to verify that all panels meet tolerance requirements. The performance of qbiss1 facade elements relies heavily on the precision of its jointing system, which ensures structural stability and weather protection. Together, the longitudinal and transversal joints create a continuous sealed facade system that offers durability, weather resistance, and long-term performance while still maintaining the clean modular appearance of qbiss1. You can choose from different joint options aligned with the architectural requirements. Main applications are a recessed, or some call it a shadow joint, and also a flat joint interfaced with the cover, or the combination of both. We distinguish between two main panel orientations, horizontal and vertical. The production process and geometry of both panel orientations are exactly the same, whereas horizontal panel is rotated by 90 degrees counterclockwise starting in the design stage. This means that the main fixation direction is also rotated from vertical to horizontal direction. Main fixation for the horizontally laid panels is vertical. For the vertically laid panels, the main fixation is in a horizontal direction. Longitudinal joint is formed by a tongue and a groove connection between adjoining panels. We distinguish between B-type and F-joint type. Dimensions of a B joints are 23 per 24 millimeters, whereas F joint type is not emphasized. Longitudinal joint guarantees accurate alignment, mechanical strength, and continuity of the facade. On the other side, transversal joint is formed at the edges of the facade elements, where the panels are fixed directly to the supporting structure using washers and screws. Dimensions of the joint are 25 per 24, and to ensure a complete air and watertight seal, the joint is finished with an inserted sealing gasket and a decorative aluminum profile. Depending on the complexity and direction of installation of the facade design, different types of transversal joints can be applied, providing both functional sealing and architectural flexibility. For your information, the different types shown on the slide will be explained later when we'll move to AutoCAD. Okay, so now let's talk technical properties. The available thicknesses vary from 80 to 250 millimeters, while panel width is available from 600 to 1200 millimeters. Length of the panel starts with 500 and is possible to up to 6500 mm. External facing thickness varies from 0.7 to 0.8 and is always with a type G profile, so it's smooth or flat. Internal facing profile thickness vary from 0.5 to 0.8 millimeters and is possible with different types of profile, so smooth, standard, microline, and so on. External coating options are PVDF, PUR-PA, and stainless steel. Internally, we mostly use polyester coating. Different corrosion environments are possible to up to C5 corrosion class environment. This is according to classification defined in EN 12944. Reaction to fire according to Euroclass is A2S1D0. So that means limited combustible, no flashover with little or no smoke, and non-flaming droplets are released during fire. We offer a big range of different colors, but we most commonly refer to qbiss.support color chart and RAL card. For other colors, please check with Trimo technical department. We can choose from advanced coatings, PVDF or PUR-PA for durability and aesthetics. The most harmful part of the element is face side. It is exposed to environmental impact, therefore it must be well protected in order to last long. I would say that we discuss corrosion with confidence. We define type of coating project by project. Only pre-painted steel sheet with the best protection on the market is being used to produce the qbiss.support facade elements. External side, so the one that is exposed to the environment of qbiss.support element, is protected with polyvinylidene fluoride or polyamide modified polyurethane protection. For the most optimal results, we can adjust protection of the element's internal side based on the building purpose. Regarding warranty, we can offer a warranty up to 30 years on corrosion of steel sheet. but warranty is discussed project to project. So therefore, please consult for every project with Trimo technical department regarding this specific project. When speaking of core insulation, we offer a non-combustible Class A1 mineral wool. It is an insulation material made of melted stone of volcanic origin and then fiberized. It is considered as recyclable component. Fire-resistant function prevents fire to spread, and excellent thermal insulation ensures low consumption of energy for heating or cooling of the building. Density of the mineral wool is between 90 and 120 kgs per cubic meter, depending on the required T value, panel span, and fire rating if required. Now I would like to point out some of the key mineral wool advantages. It has Class A1 non-combustible reaction to fire classification according to Euroclass EN 13501. It has high density for superior structural strength. It is environmentally friendly, where landfill disposal is treated as non-hazardous waste. Recycling costs are up to 5 times less compared to pure or poor insulations. It retains thermal and structural performance throughout its lifetime and does not provide the environmental conditions for bacteria growth and rodent animals. Thus, it is also suitable for construction in the food and pharmaceutical industries, clean rooms, and so on. Now, you might think, what is the deal with the A2 classification on the panel? So, as we saw while discussing manufacturing process, we add adhesive between the layers to bond steel sheet with the mineral wool. Therefore, the qbiss1 panel as a product is classified as A2 due to limited combustibility of the adhesive and is still a top class product on the market regarding fire demands. qbiss1 is distinguished by the unique rounded corner of the element. The design is the result of world-class engineering and the highest automated technology and patented manufacturing systems. Unique rounded corner provides a superior aesthetic appearance whilst also preventing any potential threat of corrosion. All other available products on the market use a so-called cut and fold design that needs to be sealed manually and then touched up with paint. qbiss1 system has successfully undergone rigorous testing in accordance with the latest Center for Window and Cladding Technology standard. Pre-installed gaskets prevent water to enter the system. Drip element serves as a secondary protection and drains water out of the system. Decorative alloy extrusion HF defines color of the joint, and together with silicone transversal gasket covers fixing elements and protects water ingress. With a wide range of aluminum profiles, we can adapt vertical and horizontal joints to either have shadow or flush joint as mentioned earlier. One of the services that Trimo provides free of charge is also a quotation stage project-based structural calculation. We start by selecting the right combination of qbiss1 panel materials to satisfy the project lengths. What differs qbiss1 from other systems regarding structural performance is a unique way of fixing that allows two panels to be fixed on the same washer at the same time. Therefore, we are required to check support reactions between the two panels. Fastening of panels is carried out with self-tapping or self-drilling screws. The main screws are fastened to the substructure through the mounting washer integrated in the qbiss panel. Depending on the width or module of the panel, the required number of mounting washers is calculated together with the suitable screws. Mounting washer is pre-installed and integrated in the production according to structural calculation and panel specification. Additionally, the inner steel sheet of the panel is attached to the substructure with short screws. So these serve as a temporary fixing for the time of installation, so the panel can hold on until we fix it with the longer main fixation screws. Once the calculations are done, the final printout shows how many washers, main and short screws need to be included per panel and per module. This printout also helps us fill out the number of fixing points on the cutting list, which we will learn about later. Fields of use: facades, perfect for building envelopes. They enhance the exterior design of both residential and commercial buildings. Available in a variety of finishes, they can complement modern or traditional architectural styles. Ceilings: these panels are well suited for ceiling solutions. Their lightweight nature makes installation easy, and they can be customized with different patterns and colors. As partition walls, they are ideal for internal divisions. Panels provide flexible solutions for offices, homes, or even public spaces. They allow for quick reconfiguration of spaces without any major construction. Panels can be installed horizontally or vertically, as we mentioned earlier, offering maximum design flexibility. This adaptability allows architects and designers to create unique visual effects, emphasize building proportions, or align with structural requirements. The installation options make it easy to achieve both functional and aesthetic goals. Customers can choose from different options of installation, such as aligned joints, brick, or asymmetrical. So now we'll move to AutoCAD, where we'll get more familiar with dynamic blocks, export data, and interactive cutting lists with accessories. Andras will take over this part, and guys, a kind reminder, Q&A section remains open.
Okay, so some of you already downloaded the package that was sent. This includes AutoCAD drawing and Excel spreadsheet. We will be working on that today. So this will be our task. We'll try to demonstrate how to design one facade. This includes corner elements on each side, two different module sizes, two different colors, the integration of door and windows. So now let's go to AutoCAD.
Hopefully everyone can see my screen. All right. I just want to say that this is my first time presenting some content, so I'd really appreciate your feedback afterwards. Make sure that you save this file together with export files to an unshared folder because some online shared folder might cause issues and so on. So here we are. We have our DWG file open and a few things already set up. So here's our key plan of the building, and as mentioned before, we'll be working on the south elevation, and we go from one corner to the other side of the building. Here we have a couple of dynamic blocks. These are the ones we'll be using. We've got blocks for creating the elevation drawings, blocks for cross sections here, and a longitudinal section as well. There are also blocks for qbiss accessories like aluminum extrusion, silicon gasket, and all the other accessories. Using these tools gives you much better overview of the element shapes and helps you manage the details more easily. Some of the dynamic blocks already include product limitations and restrictions built in, so it's harder to make the design mistake if you use these blocks. And at the end of the day, you can export all the data to Excel and use it directly for ordering the materials. Here we have already set up our grid. So this will be elevation drawing and two horizontal sections, the plan views, one at the level of the openings and another one just above. We'll make also three vertical sections, one showing the full height of the qbiss panels layout from the bottom to the top, the other one through the door, and the third one through the window. What's important at the beginning? So at the beginning, it's important to define the direction of installation, since the qbiss elements and the joints are designed with the overlapping edges. For this demonstration, I've decided to start from right corner, so this will be the initial panels, and moving towards left up to the door, and from there and also from the another side we'll start with those panels and we'll go on each side. That means to the left side and to the right to the doors. Above the door I will have the shorter panels, and I will set these panels to be produced after measurements. Due to the installation tolerances, we can set some area of the building that we take the measurements afterwards and get produced these panels after the exact measurements from site. And we'll have two different colors, RAL 7016 and RAL 9006, and with the module 600 and 1000. Now let's start with a plan view at the level just above the door. I'm going to begin with the initial panel. For that purpose, I will copy first panel and place it on our plan view. I will put it here and just make sure that it's placed on the substructure. To be within the qbiss tolerances, we suggest to go with the leveling substructure on the main structure, which is installed on the main structure, and for that reason we will have the 70 millimeter offset, and this allows us to nivellate, to level and to make the flat base to put the panels on it. So the first panel is that one. We can use the grip points to define the length and also to define the thickness of the element. So we'll already have some thicknesses here, for example, that one, and this is all built in. And we can also use the parameters in the properties window. So the first panel will be 3.5 meters, and I will just put the length here, and we're gonna have 120 thick panel. As I said, this will be our first panel. For that purpose, I will also need to put the correspondent type of the panel to have the edge of the panel on each side the same. So the adjacent panel actually overlaps the first one. So this will be the first one on that side, and on the other side we'll have the corner of the same element type 3. I've already created one corner element for that side and another one like U-shaped with 120 degree here and 150 degree here. And this is actually created using these dynamic blocks, because you can also select cut element just on the one side with overlapping edge, that's our starting edge, or you can have the whole panel. So this block is created like that. Now I will simply copy that to that side of the building. I will just use some guidelines, some construction lines. A little bit my construction line, I will put it in magenta, so the facade can be aligned as it should be. Alright, so now we have here the corner, and I can simply also insert the connection, actually the substructure. I can put it here, so I have the base to fix the panels. So we can move from that corner to what's left. For that reason, I will simply select the flat panel, put it here, and now I need to modify the total length. So this will be 5,000 millimeters. Now what I can see that I have a little clash here, because the panel ending is not correct one. For that reason, I will need to select the type 2. And I can also use the grip points here to move the panel to the right place. And now I can continue with copy of the flat panel, 2000 millimeters to the left. And now just modify the total length, which is 2000 millimeters. And I already have the correct overlapping detail on that side. Now I already came here to the door, but now I need to go, let's say, from that side. I will copy that one, so 3500 millimeters, and just modify the total length, which is 2000, and need to select the type 1 for the overlapping edge. So now I'm actually at the location of the door, but as I said before, that this that this section is at level 2, just above the door. So I will also put the panel here. 2000 millimeter, copy, and modify the total length of 1000 millimeter. What I need to do now is to actually modify also the panel type. So as I said, that the panels over the door will be the panels after measurement, and this will be also our terminal panel, and for that reason we have type 4, which is actually the last panels. So when they take the measurement from site, they just measure, let's say, from the cover, qbiss cover to the cover, and just minus 25 millimeters, which is the dimension of the qbiss 1 joint. That means that for this case we have panel 1000 in between. All right. What I need to do to complete this section, this plan view, I need to bring my U-shaped corner element. I will simply copy that group, which I created before, and I will put it here. Now I just need to check if all the panel endings are fine, and as I can see, everything is just fine. What I'll do next, I'll do the section at the level of the doors. I will simply select all the panels that I created for that section and simply copy them to the level 1. What I'll do here, I will simply delete the panels where the doors are supposed to be installed, and we will also have here one large window opening. As I created some details before, I will insert door jamb detail, so this one will be on the left side. I already have some grips here, and door jamb detail for the right hand side. And actually this is all set up with the flashing details. Next one, I will do the same for the window. So for the window jump, I can simply use the grip points to bring it here, and I will simply copy that block to the other side. What I can see, it needs to be mirrored, and I will just simply use the -1 scale in X direction. So I already set the two sections, the two plan views. What I'll do next, I'll go to the vertical sections. So for the vertical sections, I've decided to put the 3 sections. One I will do for a full height, the other one through the door, and the third one through window opening. I will bring up the base detail here. So what I can see, this is my level 0, and 2 to 6 is actually the center of the joint, of the center of the qbiss 1 joint. And next, I will use the dynamic block for the cross section. I will simply copy that one, use the grip point for the middle of the joint, and bring it to our first section. All right, what I'll do next, I'll just check if everything is fine. So I have 1/20 thickness of the panel, module size is 1000, so this is the height in our case when we have the horizontal installation, and the type of the qbiss one is BB, which is basic, so we have recessed joint in both directions. Now I will simply copy these blocks. I can use the array function. I will need 6 panels in height, 1000 millimeters. As I already mentioned, that one panel will be 600 millimeters, so I will need to actually modify that panel. So I will put it 600 millimeters. And now I need to bring down the 2 panels for 400 millimeters. To conclude the section on the top, I already created some parapet detail, the capping detail, and I will simply place it on the top of the panel. To create the next section, I will simply copy the whole section at that point. Alright, we need to put it here. I will erase the 2 bottom panels as we have our door here. And the next, I will copy all the panels with parapet detail. I will copy to the 3rd section. For the 3rd section, I will just need to erase the 2nd panel from the bottom. Actually, to finalize the sections, I will insert the door head detail with the grip points. I already can put it here. So I have 2000 millimeters from the bottom to the top. And now I will also put some details for the window. For the window, I also have the window head detail with the substructure and so on. And now I need to put the window sill. And that's it. We've set all the vertical sections with the two plan views. For the purpose of working on the elevation, I will make some guideline, some construction line at the bottom of the panel, which is actually the level of the mineral wool. This is actually our standard to measure the panel. And now next I will use the dynamic blocks for making the elevations. I will simply copy the flat element. I will use this magenta line, which is actually the module size, presenting the module size. The first panel will need to be here, and now I can simply check, as we have here the PA layers. I can also check the cross section, which appears on my drawing. And so this cross section, and I can turn on the layer for the longitudinal section as well. So now I can check if everything is fine with my level of the panel. I will just put another grid here in yellow to check if the bottom of the cover corresponds to our section. So everything seems to be fine. All right, I can erase this one. What I'll do next, I will create the elevation drawing. So my dynamic block needs to have some setting. I will need to set the length of the first element. This will be 3,500 millimeters. The thickness of the element is 120 millimeter, and the type, as I said, this will be the initial one, will be type 3. I can also select the representing color, and this will be 7016, RAL 7016. Okay, and I can check all the other attributes. So this is the horizontal installation. The external face of the panel should be RAL 7016. The thickness of the steel sheet 0.7. This is actually all this data is given on your offer. And the profile is smooth, like G stands for Gladio, and PVDF is the coating of the external steel sheet. And then we'll have the mineral wool. We'll put power T, either it's power T or power S. This is actually defined in the structural calculation of the panel. And for the internal side of the panel, we have RAL 9002, 0.6 millimeter thick steel sheet on the internal sides, S profile, standard polyester coating, and the number of fixation screw is also defined in the fixing calculation by our structural engineer. And we'll have 3 fixing screws per qbiss joint. What I'll do next, I'll simply copy these blocks with the array function, just what we've done before for the vertical section. Actually, I will have 6 panels, 1000 offset, and this one will need to be 600 millimeters. And as I said, this one will be of different color, 9006. And I will also modify that one. And for decorative profile, this is aluminum profile that is actually factory applied on the panel, will have the same color as the steel sheet. What I do next, I need to bring down those 2 panels for 400 millimeters. What I can do next is simply copy these dynamic blocks for the second panel, which will be here, and I will quickly do the same what I did before. So this panel will be 2000 millimeter long, and copy that to the next one, 1000, and modify the length, 1000, copy that one, 1000, modified 2000 millimeters, copy 5000 millimeters. All right, so what I'm gonna do next, I will delete the panels where the doors, where we have our door, and delete one panel for the window. And what I'll do next, the next we'll need to create the corner element. So for that reason, we have two different corner elements. It's transversal corner element of 2-leg corner element and 3-leg, like for U-shaped corner element. So on the right hand side of our elevation, we'll need to have 2-leg corner element. I will simply copy that one here and bring the leg that is actually visible on that elevation here. What I need to do next is actually define the module size, the A corner leg. So the A corner leg is like that, is 1000 millimeter and B is 800 millimeters. So A 1000 and B actually on that elevation is 800 millimeters. And the thickness of our panel is 120. As I said before, this is our panel type 3, like initial panel. And I just need to check if all the other attributes are fine. So we have the horizontal installation, the color, the thickness, and so everything is fine. What I'll do next is I will simply copy those blocks. And modify this one 600 and modify the color and bring down 400 millimeters. Sorry, I made a mistake. Just a second. Alright, 6. Alright, so these corners are all set, and now I will bring the other corner on the other side. I will just move a bit the legs that are not visible on my elevation. So the corner leg sizes are A is 800, B 1000, and C 800. So model size fine, 800, C 800, 120 thickness, type number 2, and 800B. I just need to check that all the other properties, these are fine. So everything is fine, just the first angle I said is 120 and second one is 150. I can check it also in my key plan. Okay. I just need to bring it. When I changed the dimensions, it also changed the position of the panel. I'll simply copy as I did it before and modify this panel to 600. Okay. Yeah, If you're asking yourself what these arrows are for, so these arrows are actually showing the direction of installation. So when we have type 3, these arrows are on both sides. So I need to actually to modify all the other parameters for the panels. So in this column, I will have my panels type 1, as we already set it in our plan view. And the panels above the door will need to be panel type 4. And I will put a note that this panel will be after measurement. Yeah, measurement, yes. Okay, and from the other side we go from that corner, which need to be also type 3 as initial panel, and then we'll have these panels type 2, and also this one type 2. Why I skip this one? Because I need to have some detail like shown here. Let me just check if I put it correctly. No, so I forgot it. I need to put this panel type 3, and here it should be type 2. Okay, so I have the panel ending on each side of the door and each side of the window the same, like that. Okay, now we've created our elevation drawing. Let's check it in our paper space, so I can see everything looks fine. And now I can just simply freeze some section, cross section and longitudinal section, and I can show also the attributes. Okay, so I can see that I have 3 fixing points, and my module is actually able to receive 5 fixing points. Okay. But that one of 600 is able to receive only 2 fixings, so I will need to set these panels to 2 fixing points. Two, because it's maximum, and also the corners, and also this one. Okay, what I'll do next, maybe I can show you also some hidden attributes. So all the attributes are also written on the panel under the layer hidden attributes, just like that. So what I'll do next, I'll export those panels to some text file, and I'll try to use the Excel to put some position numbers on my elevations. So I can simply select one flat panel and say select similar. Make sure that you don't have selected any other panels, for example this one. And now regenerate our drawing and simply go to Express Tools, Export Attributes, and select this file that was already sent also to you. and save and replace. What I'll do next, I'll go to the Excel spreadsheet, simply refresh. Okay, and now I can select some prefix. I will put S for south facade, start the number with 1, and say that this is our south facade. And face, I will set that is my first priority. Like that. Okay, I can see that what I put in our drawing, some panels after measurement. It's already written here. Now I will bring these position numbers to our Excel. What I need to do is to select the header of this table. Don't forget to select the handle, because this is actually related to the blocks, dynamic blocks, and I will select this data to import. Okay, now I just select the position back to AutoCAD and save. Okay, now I go back to my AutoCAD drawing, regenerate, and import attributes, positions back to AutoCAD. Okay, what I can see, I already have my panels with the position numbers. Just make it more clear, I will hide all other attributes. So I have the direction of installation shown by this arrow, and the position number here in circle. What I'll do next, I can simply do the same for the corner elements, but before I do that, I will again select all the flat elements and export all the data again to this text file, and that will bring me some other naming here, like existing position. Just quickly refresh this table and I can see that it shows up here. What I'll do next, I will go to tab qbiss one element. This is for flat elements, and simply refresh this table. Okay, so here I have written my face, element reference number, our position number, the quantity, and all other data. This data can simply be copied to our interactive qbiss one cutting list. So I'll have here the webinar project. I will have the corner, transversal corner element, and the U-shaped corner elements, and I will simply go to the tab qbiss one elements and copy, because quickly select and copy the data here. What I see that I already have also the square meters of my facade. but I need to put the nodes, which I already have here. I can bring the nodes also from the previous table. Okay, so I have horizontal installation and the two position numbers S10 and S11 for the panels after measurements. So these are S10 and S11 above the door. And I can simply do the same thing for our corner elements. But now I will just try to explain about some qbiss accessories. So here you just define the total length of the aluminum extrusion. This is actually for our horizontally installed facade. These are the extrusions that come into the vertical joint of the two panels, and these extrusions are supplied in 4-meter length pieces. So you just need to define the color and the number of the pieces. And the same goes for the silicone transversal gasket, and you simply define the linear meter of this gasket. And then we have some junction drip element that is actually the drip element in between 2 or 3, 4 panels. And then for some special detailing, we have EPDM cube gasket, and for example, for the bottom of the facade, we use the EPDM drip element, and for some cut panels, stainless drip element, some load-bearing fixing plate, because some of the panels already have the pre-installed plates factory applied, but where it's not, it needs to be ordered separately. This goes especially for some details in the perimeter of the windows and the doors and so on. And then you receive also some installation kit. And for other accessories, it's actually what's actually included into your offer. If you also deliver some fixings and so on. So now I can just check if everything is fine in our paper space. So I hope that you got some insight and you learned something new.
So now we go to Q&A. We have received quite a few questions, and we will not probably be able to respond to all of them, but you will receive their answers after the webinar. So Yuri, if you can, just a second. So maybe this one. What exactly does it mean that the qbiss One panels are factory made and ready to install? Does that mean no cutting or adjustments can be done on site at all? So yeah, basically all the panels that are produced here are ready to install, but when it comes to some specific detailing and some endings, finishing, maybe there might be need for some cutting or adjustment. But it's also important that when you design all the panels with different properties, that means the length, the size, the module size, the color, the thickness, and so on, has a different position number. That means also that it's easier for the installers, so they know exactly where they need to put the panel on the facade. I believe that. Yeah, I think you answered this one. Okay, next one. Oh, this one. If Trimo provides structural calculations free of charge,
Does that mean I don't need to hire an engineer for my project?
Yeah, basically it's true. It's true for the panels for the qbiss one element, because we provide the structural calculations for all the areas of the building for regarding the qbiss one elements. But when it comes to the structure, the main structure or the substructure and some details, you will need the structural engineer by yourself. But anything that's related directly to the qbiss one, it's calculated by us. Okay.
Also the file system, the substructure system.
So it depends. It must be actually discussed in the offering stage. If you also provide the file system, the substructure, the leveling substructure, we can also provide the structural calculation for that. Yeah.
Okay. So perhaps something related to export. Yeah. So my software doesn't support the export as shown. What do I need for placing order?
Okay. So it should work with AutoCAD Classic. But when it comes to maybe for AutoCAD LT or mechanical, maybe there might be some issues with that. But you can contact us after that webinar, and we can take a look together. But what was the other part?
What do I need for placing order?
Yeah, for placing order is actually you can also fulfill the interactive cutting list manually also. So it's also fine for us. So yeah, I believe that's it. That's it. Yeah, I believe I answered the question.
Yeah, we are running out of time slowly, so just perhaps move to.
Okay. So yeah, as you see, the full Trimo library is available on our website. You go under the download section, design tools. Just make sure you select the English language. If you need any other documents, you can contact us. And make sure you visit our YouTube channel, and where you can learn also some other things and a lot more. And also a recording of this webinar will be uploaded to that channel.
Hopefully it was helpful, right?
Yeah. Thank you, guys, and see you at the next webinar.
Yeah, thank you. Bye bye.
Bye bye.